Let's try some operations with radicals. Let's distribute a pair of binomials. So we have 6 radical 2 add 1 times 4 radical 2 take away 4. So this is the FOIL method. We're going to multiply the first terms together. So it's 6 radical 2 times 4 radical 2, which of course is 6 times 4 is 24. And radical 2 times radical 2 is just 2. So it's one big product you can multiply by grouping. That's the first terms. We want to multiply the outer terms. That's going to be minus 4 times 6 radical 2. We want to multiply the inner terms. So that's going to be plus 4 radical 2. Okay, so what we have here is minus 24 times the radical and plus 4 times the radicals. So minus 24 plus 4 is going to be minus 20 times the radical. And finally, in terms of FOIL, we got to multiply the last terms together. So it's going to be 1 times negative 4 or negative 4. I'm going to bring that down. So 24 times 2 is 48. Minus 20 radical 2. Whoops. Minus 4. Now, don't make a mistake. You can't subtract 2 from 48 because this quantity involves a radical. This is just a whole number. But we can work with the 48 and the minus 4 because they're both numbers. So 48 take away 4 is 44 minus 2 radical 2. You can't go further. It is incorrect to say 42 radical 2 because subtraction does not have the priority over the multiplication. So the right answer is this answer on the left. Let's take another problem where we're distributing, but instead of, it's a little easier problem. It's the square root of 2 monomial times the square root of 32 minus 4. So let's distribute square root of 2 times the square root of 32, which of course we can multiply the radicals together and say square root of 64, which of course is just 8. And going back and continuing the distribution, it's going to be minus 4 times the radical 2. Let's carry that down. And again, we can't go any further. We cannot say 4 radical 2 because of the multiplication here. And we have to multiply before we subtract. We now would like to add some radicals and simplify. So we have minus 6x square root of 5x cubed y to the 4th. Add to that x times the square root of 5x to the 5th y squared. We're unable to add at the moment because these are unlike radicands. We should simplify the radicals first and see what happens. So I have minus 6x. Separate the radical into 2 pieces, perfect squares, x squared y to the 4th here, and underneath the other radical, 5x. Plus x, separate the radical. We're going to have x to the 4th y squared, and then we're left with radical 5x. Take the square root of what we can, and I'm seeing a little bit of a mistake here. See, x, erase that out. It's x, y, x to the 4th. I'm sorry, I can't read my writing. X to the 4th y squared. Okay, so we have minus 6x. The square root of x squared y to the 4th is xy squared times the radical 5x plus x times x squared times y square root of 5x. We can do this multiplication, which is negative 6x cubed y squared square root of 5x. And this would be x cubed y square root of 5x. Okay. If this y were y squared, and it isn't, we would be able to combine these two terms into one big term. We really can't do that. We have to leave it the way it is. But the only thing we could do is extract. We could write it this way. We could say x cubed y square root of 5x. Take that from the first term, x cubed y square root of 5x will be left with minus 6y. And take x cubed y square root of 5x out, we'd be left with plus 1. I normally wouldn't do that, but I just want to show you that that's a possibility. I'd rather leave the answer as I had, two terms that could not be combined. Now let's try this numerical problem. Might be a little easier. The square root of 72 minus the square root of 50. Again, we can't subtract yet because they're not like quantities, but we can break 72 maybe into, well, 9 and 8. But how about maybe if 9 and 8, that's, well, let's do that, 9 and 8. But 8 is 4 and 2. So how about 36, which I couldn't think of? 36 and 2, that's 72. And for 50, how about 25 and 2? Taking the square root of 36, we have 6 radical 2. Taking the square root of 25, we have 5 radical 2. Now we have like radicals. So we have 6 of these radicals, take away 5 of those radicals. So we have 1 of those radicals, or just the radical.